Alrighty then, let's keep going. So we need to define some words, and the first word we're going to define is trial. A trial is an action that has multiple possible outcomes. So if you flip a coin, that's a trial. If you roll a pair of dice, that's a trial. If you bet on a football game or you bet on who's going to come through the door next, anything that is uncertain that you're going to repeat, it's an action that you can repeat over and over and over again. Each time when you do that, that's a trial. So the events are the outcomes of those trials. So if I flip a coin, the possible events that could occur is heads and tails. If I play roulette in the United States, the possible outcomes that can occur are 0, 00, and the numbers 1 through 36. If I play in Europe, there's no 00, there's only the 10. In the Olympics, I can get a gold, a silver, or bronze, or just lose. Those are my 4 possible outcomes. These lists of outcomes, these lists of events are called the sample space. So we need to create a universe in a statistics problem, in a probability problem. The universe of all possible outcomes has 2 characteristics. Characteristic number 1 is that it is exhaustive. That means it adds up to 1. The probability of each part, when added up, gives us 100% or 1. So the roulette wheel, 0, 00, 1 through 36, there's no other possible outcomes. If we added the probability of each one of those numbers showing up, we would get 100%. At the same time, these events are mutually exclusive, which means no 2 of them can occur at the same time. You can't spin a ball around a roulette wheel and get the 5 and the 10 at the same time. You can't flip a coin and get heads and tails at the same time. One or the other is going to occur. So exhaustive and mutually exclusive. Whenever we deal with a probability problem, the sum of all the probabilities has to equal 1. And the individual probability, the probability of any event, is somewhere between 0 at the bottom end, it could be 0, or it could be 1 at the high end, could be 100%, something in between. As an example, we have 28,000 students at UNLV, 15,400 are women, and 12,600 of those are men. So if we pick a student at random, what's our probabilities? Well, the probability of getting a woman student is 15,400 divided by 28,000 is 55%. And the probability of getting a male student is 12,600 divided by 28,000, which is 0.45. So you notice the 2 of those numbers are both between 0 and 1, and the 2 of them, when added together, equal 1. We call these numbers simple or marginal probabilities. So we can say the probability of a woman student is 0.55. That's a simple or marginal probability. The opposite of that is what's called the complementary probability. So the probability of a man, we didn't actually have to calculate, because the probability of a male student is 1 minus the probability of a female student. That's complementary probability. Since the 2 of them add up to 1, we could have taken just 1 minus 0.55 and gotten 0.45 and not tried to do the division too. So complementary probability is 1 minus the simple or marginal probability. We can get it slightly more complex here and say, hey, we have 28,000 students, 7,000 are grad students, 9,000 are upper division students, juniors and seniors, and 12,000 are freshmen and sophomores, lower division students. We can do that math and see the probability of a grad student is 0.25, the probability of an undergraduate is 0.32, the probability of a lower division student is 0.43, and if we add up the graduates, the upper division students, the lower division students, we get the probability of a student, which is 1. So now, what's the probability that you are a woman graduate student? We call that the joint probability, and we write it out as P parentheses W comma G, or P parentheses W, a thing that sort of looks like an upside down U, but really is the word intersection. So we would read these things up there as probability of W intersect G. We got that? The probability of W intersect G. That's the joint probability. It's not as easy to calculate as you might think, because even though women are a majority of students, it still turns out that men are the majority of graduate students. So you can't just flip the probabilities and say, because women are 65% of students, then the probability of women is 65% of it. It doesn't work that way. It turns out that the world's more complex than we would think. So we want to talk about this whole intersection thing. We can do it on what's called an Euler diagram. That's EULER, and why it doesn't say that, I don't know, but it should. So let's fix that. Euler diagram. That's an R, but you knew that. So the intersection is we have all these women students, we have all these men students. An intersection would be we want the graduate students. So we want the probability of a graduate student, and we can show that by just taking this Euler diagram and drawing some circles around the graduate students. And go, oh, look, those are the graduate students. So we also have what's called the union probability. That's the probability of you being a woman or a graduate student. So in that case, the probability of W union G, that's not really a U, it's a thingy there. It's not really a U. It just looks like a U. So we say the probability of woman union graduate student. So all women would be in this group plus male graduate students. So it would be a fairly large group. And again, we can draw an Euler diagram of that union, which is all women plus male graduate students. Okay? Then we have something called the conditional probability. The conditional probability is the probability of one event given that another event has already shown up. So if I have a pair of dice, I'm going to roll them one at a time. I roll the first one, I get whatever. My goal is to roll a 2 on the second one. Well, if I roll a 2 on that first one, it doesn't affect the chance of me rolling a 2 on the second one. It's still 1 in 6. Okay? But if I'm a football team and I don't make the playoffs, the probability of winning the Super Bowl changes. Right? At the beginning of the year, there's a probability for any team to possibly win the Super Bowl. Once we decide who's in the playoffs, the teams that aren't in the playoffs all of a sudden have no probability of winning the Super Bowl, and the teams that are still in the playoffs have a higher probability of winning the Super Bowl. So that would be a conditional probability where the probability of something changes because something else already happened. So you're playing blackjack, one deck of cards, there are 4 aces already up on the table. Can the dealer give you an ace if you need an ace? The answer is no. So the probability of getting an ace when you're playing cards changes as you play because those aces get used up and now you don't have any more. We have this fabulous word independence, and it simply says that 2 trials are independent if the probability of the second one is unaffected by the outcome of the first. So when we roll those 2 dice, it doesn't matter which one of them is first and which one of them is second. It doesn't matter what happens on the first dice. They're just independent of each other. But who wins the Super Bowl is not independent of who made the playoffs. So what's the probability Serena Williams wins 4 majors? We have this up and down line sort of thingy, and we say the probability of 2 given 1. That little vertical line in between 2 numbers in a probability equation means the word given. We say given. So what's the probability Serena Williams wins 4 majors? Well, the probability of winning 4 improves if she wins the first one. And the probability of winning 4 improves if she's winning the second one. Those are not independent events. So there's a conditional probability there. And if she loses the French, the probability of winning 4 goes to 0. So again, the probability of winning 4 is conditional on her results in the first 3. All right, so there's some laws in probability. They're not really laws, but we call them laws because it sounds better. So law number 1 is the complement law, which is that the probability of A is equal to 1 minus the probability of not A. probability of winning the Super Bowl is 1 minus the probability of not winning the Super Bowl. The probability of winning the U.S. Open is 1 minus the probability of not winning the U.S. Open. The probability of rolling a 2 is 1 minus the probability of not rolling.